I'm going to discuss a model for diet reconstruction. It's a rather complex model and it's presented in this paper, and I will include in the description of this video the link to this paper. Now, the goal of this problem was to quantify the contributions, the dietary contributions from three different food groups, terrestrial plants, terrestrial animals, and freshwater fish, towards human consumers. In terms of dietary proxies, there were four. There was carbon and nitrogen isotopic signals. Carbon and nitrogen isotopic signals measured in human bone collagen, and carbon isotopic signals measured in the bioapatite bone. Finally, there was also the sulfur isotopic signal measured in bone collagen, but this corresponds to the amino acid methionine. Okay. In terms of the offsets, these are the values that we used, and the reason for the choice of these values is described in the paper. When it comes to the carbon values, this is the result of a meta-analysis done on previous results from feeding experiments on omnivorous mammals, and the results of this meta-analysis are published in this paper, in case you want to know more. Okay. So coming back to the problem, in terms of how these consumer signals are defined, here I used a weighted model. So the consumer carbon isotopic signal measured in the collagen, well, that was defined by a contribution from two fractions, protein and carbohydrates and lipids. So 74% from protein and 26% from carbohydrates/lipids. In the case of the consumer carbon isotopic signal measured in the bioapatite, that was determined by the source carbon, the entire carbon. So the combined protein, carbohydrates, and lipids. So I think I refer to this as bulk carbon. Okay. The nitrogen isotopic signal measured in collagen, that was fully determined by the food source protein, and the sulfur signal from the methionine, this is an essential amino acid, so it was fully determined by source methionine. And this is, of course, a concentration dependent model. Okay, so let's look at the implementation of this model in fruits. Okay, and I have that somewhere here. So here I have different consumers, but I'm just going to model the data for one. So 1, 5. Okay, so model options. It's a weight model, offset dependent model, and concentration dependent model. Dietary proxies, we have the four. So the carbon and nitrogen isotopes measured in collagen, then the carbon isotopes measured in the bioapatite, and the sulfur signal from the methionine. So here are the consumer data and uncertainties. The three food groups, terrestrial plants, terrestrial animals, and freshwater fish. The fractions. Okay, so we have the protein, and this energy means carbohydrates combined with lipids, the methionine, and the bulk, which is the signal that which is the fraction that will determine the signal of the bioapatite. Okay, so offsets and weights. So, okay, more. So the offset values you can see here for collagen versus source, that's 4.8 minus 0 minus plus minus 0.5. For nitrogen and collagen it's 5.5, for bioapatite it's 10.1, and for methionine it's 0. In terms of the weights, let's start with the easy ones. So the collagen, the only signal contribution comes from protein. All the other values are set to 0. Methionine, only from food source methionine. All the other values are set to 0. Bioapatite, 100% from the bulk and carbon signal. All the others set to 0. But in the case of collagen, we have 74% from protein and 26% from energy. And as I told you before, this means carbohydrates and lipids. Okay, let's continue. Food values. So this looks a bit complex, but it's actually quite simple. Let's take as an example the plant food group. Okay, so the plant food group here, and we have here the dietary proxy, the carbon isotopic signals from collagen. Well, that's determined from the carbon isotopic signals measured in protein and in energy, that's carbohydrates and lipids. So I have to plug in the values, so I plugged in the values for each one here. So this is minus 26 for plant protein and minus 23.5 for plant, in this case carbohydrates, mainly carbohydrates for plants. Then plant protein determines the nitrogen signal in bone collagen, and the value for this plant protein is 2 per mil. The bulk signal for plant determining the bioapatite signal, that's minus 24, and the plant methionine signal determining the sulfur signal in the consumer, that's 9.7. Okay, and for the other food groups, it follows the same logic. Okay. Now this is a concentration dependent model, so we have here the values of the concentration of the different fractions, but there's an important point here, is that this bulk value here is set to 100, and you might find this strange, since now the addition of the 4 different fractions is no longer 100. Well, actually in fruits it doesn't need to add to 100. What is important is the relationship among these concentrations, and by definition bulk is the whole carbon, so that will be protein plus energy, which adds to 100. Here I'm ignoring methionine because the concentrations of methionine are very small compared with these ones. Okay, and these concentrations are expressed as carbon or calorie concentrations, which will be approximately the same. Okay, so what really matters here, I just want to emphasize this, that what really matters is the relative amounts, how these values are expressed relative to each other. Okay, but it does have some implications in the interpretation of the data, and I'm going to show you this next. Of the interpretation of the estimates, of course. Prior info. Well, I use the prior in which the contribution from protein, so the relative contribution from protein, that's protein divided by protein plus energy. Remember, this energy is carbohydrates plus lipids, carbohydrates plus lipids, exactly, has to be more than 5% and below 45%. Now, this is actually a conservative prior. Now I'm using less conservative priors, 10 and 35, but at this stage of my research I opted for more conservative priors, so this is the Y of these values. And what does this mean? Well, there's a minimum humans need a minimum consumption of protein to build body tissue and perform different body functions, and there's also an upper limit for protein consumption. If it goes beyond a certain upper limit, one will undergo protein poisoning. And so this prior helps to constrain model estimates, making them more precise. And this is a purely physiological prior, okay? And actually conservative, as I mentioned before. So we only have our one consumer, so we'll press estimate, and let's see what comes out of this. Because there are some important aspects in terms of interpreting data, given the complexity of how this model was defined. And you can see that the generation of estimates takes a bit more time than usual, exactly because of this complexity. So let's wait just a few more seconds. It should come out promptly. Okay. So we have here the box plots expressing the contributions from the different food groups, and here expresses probability distributions. Okay. And since the concentrations were expressed as carbon or calorie concentrations, these also express the calorie contributions coming from each food. Okay. And in the results report, these main estimates correspond, of course, to these box plots and to these probability distributions. So in the case of this individual, he had a caloric contribution of 64% plus minus 15 from plant foods, 22 plus minus 15 from animal foods, and from fish 14 plus minus 8. Okay. Now, estimates on the contribution from the different fractions. Notice that the value from methionine is extremely small because the methionine content compared with the other fractions was so small. And then we have from bulk 50%, and from protein 11, and from carbohydrates and lipids 39. Now, it's not a coincidence that these two add to this 50% of the bulk, because by definition we define the concentration of the bulk as being 100, and so the contribution of the other two, they add to the remaining 50%. So actually, if you want to report what was the protein consumption by this individual, it was actually double this. So it was actually 22% plus minus 6%. And a level of protein intake of 22% is rather high, and it's typical of hunter-gatherers. Modern Westerners and farming populations typically have values below 20%, so this is already rather high. Now we have the estimates on the contribution of the different sources towards each signal. Okay, so for instance, in terms of the bioappetite, since by definition it corresponds to the bulk, it gives you the same contributions at the same numbers as this main estimate. So for example, plant 0.6359, 0.3659. Okay. We have here the information of how much sulfur contribution was made by the different food sources. So it's predominantly coming from animals and from fish, because they have a higher terrestrial animals and fish, because they have higher methionine concentration than plant foods. This is also very interesting here. So the contribution towards the nitrogen signal in the consumer, because this nitrogen signal is only defined by protein. So this estimate here is telling you how much protein the different foods were contributing. So plants was only contributing with 30% of the protein, and the remaining 70% were coming from the terrestrial animals and from fish. And finally, there's also the contribution from the different sources towards the carbon in the collagen. And here I'm particularly interested in knowing what was the contribution from fish, because consumption of fish will have an impact on the radiocarbon dates. So this value tells me what will be the magnitude of this impact. So there's a lot of information here. And now I would like to end with the usual warning. Although I'm using these values here for the offsets and for the weights and for the concentrations, I would like to, so here for the offsets and the weights, again, I would like to emphasize that foods is in no way linked to these values, and I would encourage the user to define his own values after doing literature compilation and checking his own data. And for now, I think that is it.